Okay, good morning, good evening. Welcome, everyone. Thank you for attending. Hope everyone is safe. This is Joe Spizak. I'm the product manager for PyTorch. I'm joined by James Reed, one of our tech leads on the project, focused on core development and compiler. Today, we're here to talk to you about kind of updates on PyTorch in general, but dive a little bit into the newest features, and kind of give you an idea of the broad spectrum of things that are relatively new around the project. And then James will be covering a deep dive into JIT, and we'll dive into the next slide, which has the broader agenda. So we'll start with the community growth, the usage of Facebook to give everyone kind of a grounding of the examples of how it's used. Talk about a little bit of the PyTorch background and motivations, why we do what we do as a project. The PyTorch 1.4 release and the latest features that are enclosed there. Then, as I mentioned, James will do a deep dive into TorchScript for a little bit to kind of give everyone an understanding of kind of the beating heart of PyTorch, the motivations behind it, how to use it, some of its design principles, etc. And then we'll finish up with a few slides on our partners and really how to get started with PyTorch. So starting with PyTorch and its growth, which has been pretty incredible. I've personally been on the project for over 2 years, and it's just been amazing how it's kind of gone from this small, scrappy, organic project to really being this big, scrappy, organic project. We have over 1,300 contributors now. I think it's closer to 1,350 now, growing over 50% year over year. We also have over 26,000 forum users on the PyTorch forums. This is a fantastic place to learn, ask questions, answer questions, engage, really understand what the cutting edge researchers in the world are doing. So highly recommend checking those out. From a metrics perspective, this is a great chart that's on Papers with Code /trends. If you get a chance to check out Papers with Code, it's a very great, very amazing repository of information and provides you a lot of really great data on what the state of the art is in any field, but also in the trends section, they show the implementations on GitHub and what repos and what percentage are using what framework. So it kind of gives you an idea of who's using what. And PyTorch is doing fairly well, which is great. Also, some of the things we look at in metrics are around archive and how many mentions of framework. And so we do track that, which is really interesting to see. PyTorch has had this kind of rise from really nothing to in 2017 when it was just introduced to really going into the top spot as far as like archive mentions. So let's talk briefly about PyTorch at Facebook. So we at Facebook have a number of different teams. We have product teams, we have fair research, we have applied research, we have AI infra, and a number of other organizations around who actually do perform some level of AI ML development. And just to kind of give everyone a broad view on some of the areas that PyTorch is applied. This is a great visual. Really shows the multimodal nature of Facebook products themselves. This is the Facebook Blue app. You can see we have search. We have things like face tagging. We have newsfeed, which both of those are, or at least search and newsfeed are very much ranking algorithms. Face tagging, obviously, computer vision, translation, as well as ads themselves. So this kind of gives you a broad spectrum of some of the applications that we have. If you kind of dive a little bit deeper into one of these, in the integrity space, we have things like hate speech. We're applying NLP, so really, models like transformers, which are pushing the state of the art these days in, things like detecting, these types of things. So obviously, my friends are killing it is a very positive statement, and so we want to be able to decipher whether that is a positive statement or actually a negative statement, and NLP allows us to do that. And then, of course, if anybody has a portal, The portal products are really great, and we use on-device neural nets for computer vision, so really detector on to go, if anybody's familiar with that, to really move the smart camera around and really provide a really immersive experience. And this is purely running on the device with no information being sent back to the server. Okay, switching gears over to the PyTorch project background and really the tenets for how the project operates. So when we look at PyTorch, really providing an eager and graph mode execution. So one of the things that's been incredibly popular, incredibly important for researchers is that flexibility, that eager mode. So PyTorch has been eager mode from the beginning. So really providing this open world Pythonic environment for quick iteration in the research world. But we found that we need to also support a graph mode execution for large scale deployment, for efficiency, for a number of reasons. And so building on PyTorch 1.0, which we released in 2018 at the end of the year, supporting eager and graph, but basically providing an elegant way to migrate between the two. Also, this notion of dynamic neural networks. Again, from the beginning, we saw that there was this trend towards control flow and NLP with these variable length data objects. Really, this that the world was not static. I mean, shapes were dynamic. Data lengths were variable. So we needed to have something that was truly dynamic. Thirdly, these models are not getting any smaller. There is this huge trend of getting bigger and bigger, models that are around that transformer architecture. There are also a lot of efforts to compress them down and distill them down, but we still see a lot of the state-of-the-art pushed around larger and larger models. So distributed training continues to be something that is a focus for PyTorch. So whether that's distributed data parallel, elastic distributed training, model parallel through the Torch RPC framework that we open sourced back in PyTorch 1.4, or otherwise. So this is a really big part of the project and always has been, and will continue to be. Fourthly, hardware acceleration. In this case, this could be, for example, cloud TPUs from Google and supporting those through the XLA compiler, but also GPU inference, which is getting more and more popular, especially with the autonomous driving companies, many of which use PyTorch today. And lastly, simplicity over complexity. The API for PyTorch is something we handle with care. We treat every API that we add to the framework, with a certain level of rigor, and really don't add a lot of fat to it. We really would like to have this, one way really to do things, if possible, a clean way to do it. And so anything we add to the front end, we consider very carefully. And so as a result, you see, the overall API is very clean. It's much easier to use than maybe projects in the past. Cafe 2, was a lot harder to use, and so people migrating, especially at Facebook, from Cafe 2 over to PyTorch are certainly delighted. And then if you look at really fundamentally what we're trying to do with PyTorch, it's building this research prototyping to production deployment. That is our mission in a lot of regards. And we're building community externally, and we're building community internally, and we're shipping product to Facebook. But at the core of all this is really this research to production story. And underpinning that story is really two principles. One is developer efficiency, and the other is building for scale. We'll talk about both of these and some just kind of a few examples of how we're doing each. So starting with developer efficiency, what this concretely means is we are enabling high velocity of model iteration and innovation. So what are the types of things that we do to achieve that? Number one, as I mentioned, clean APIs. So if you look at, for example, some of our libraries like, nn.transformer, this was basically, allowing, developers to have a single API that allows you to really harness the power of things like self-attention and transformer architecture. So, when you don't have to write hundreds of lines of code to implement a transformer, you can apply them really as, layers or modules within your uh, your overall architecture. This actually gives you a lot of power, and you can see the API here, and it's been adopted by some of the top labs in the world. And we are also refactoring it, making it even more flexible for the next release. Torch script. James will definitely dive a lot deeper in here, but really providing this really easy and clean way to annotate your code and kind of lightly refactor it, but very easily remove any decorators if you want to go back to like eager mode, but really providing this stable subset of Python that basically can run in, for example, a C++ environment. So it's this models of our programs idea. It gives you a really great migration path to production deployment. There's no GIL, global interpreter log for Python, and you definitely get performance optimization via compilation. So this is again, James will dive a lot deeper into this, but these code examples on the right give you an idea of just how to load it into a C++ program, starting from really a pure Python development workflow. So this has been incredibly popular at Facebook, and we have seen a number of large companies adopt this because it's so elegant. Next, TensorBoard. So this is something that we started development, more than a year and a half ago with Google, and we started to collaborate on, bringing, PyTorch as a first-class citizen to TensorBoard and removing, for example, some of the other dependencies like TensorFlow. And we released that in, more than, I guess, a year ago now, or almost a year ago, I guess now. And so this is a really great way for for anyone to visualize, for example, like we're showing here, embeddings, but also your data sets, loss curves while you're training, and we're contributing a lot of features to TensorBoard, from our team, our core PyTorch team. So incredible tool. We love it. We use it across the board at Facebook, and we continue to upstream contributions from our team. Okay, so going back to our principles, let's kind of switch gears and talk about building for scale. So what we mean by building for scale is really high performance execution for model training and inference. And so this is a big topic, obviously. We could say a lot here, but just giving you an idea of some of the things that we're enabling underneath PyTorch to support this. So of course we support the canonical MKL or MKLDNN and CUDA and cuDNN, but we also support things like QNNPAC, and then in an upcoming release we'll support XNNPAC, developed by Murat Duncan over at Google and previously at Facebook, and then of course the PyTorch JIT, which really provides this great compiler pass and JIT compilation support within the framework, and this eager to graph mode path, but also some of these other backends that we're supporting. So XLA is a great compiler that we're working on collaboratively with Google on to support cloud TPUs with PyTorch, and also compilers like TVM, which use a halide approach and provide really a great auto tuning environment to support kind of non-standard hardware backends. So we have a number of developments along this line. And our goal is overall to keep that PyTorch development environment as clean and as kind of um, approachable as possible, no matter what the exotic hardware backends are that are being supported. Okay, so I want to give everyone now a quick update on the latest features, and we'd love feedback on these. Try them out. Tell us if there are rough edges, if there's new features you'd like within these features, and so on. Okay, so let's start with name tensor. So this is an experimental feature that we'll be bringing into stable this year. We've gotten some great feedback on this. This is something that we think is a long-term way of code development. So in this case, instead of having code comments throughout your code, which can certainly go stale or could be just flat out wrong, especially as we move to like different ways to lay out memory. As we have like, for example, channels last, being very popular right now because actually performance is there's performance benefits to putting your channel your C at the end of this. So instead and CHW, the C is at the end there. We'll talk about that maybe later on in another release. But really taking this existing code and being able to refactor it and not have comments or not allowing the comments to get out of whack with the actual code itself. So you can see at the top here where there's a tensor NCHW that actually maps over to the torch.random, which is basically creating a random tensor of this configuration. And you can see in this case, we're actually using labels and instead at the bottom. So in this case, the labels are kind of built in to the actual to the torch.random call, and so there's really no label to no code label to actually comment to take into account. This makes it super clean, and it also makes it much more readable for anyone else who's looking at your code. We also released in 1.4 Java bindings, and we tried to keep as you can see, the Java docs as close to what the community and the Java community likes. And these are, right now supporting just Linux and also just inference. But it's something we plan to invest in and add, support for things like Windows. And we don't see a huge demand right now for training in Java, but if there is, definitely reach out or file an issue or contribute. But want to make aware that this is there and it's available. And if you go to the PyTorch site, there's a link to the documentation. And again, it's in the Java doc style, so hopefully the Java community likes it. We tried very hard to keep it close to what they like. Captum. So we announced Captum last year at DevCon. There's been a number of new features added to Captum, including Captum Insights. So especially in this latest release that went out this past week, we added a number of attribution algorithms. So definitely check out Captum.ai and what we have going on there around model interpretability. PyTorch Mobile. So we announced PyTorch Mobile in 1.5, sorry, in 1.4, and this is an end-to-end workflow for mobile and iOS and Android. Again, there's no separate runtime to export. We're going to be supporting build level optimization and selective compilation, which actually was added, sorry, in 1.4. We will add things like whole program optimization with link time optimization in a future release. But really looking at the workflow here on the right, so there's not much that changes from a user perspective. You still author a model in PyTorch. You may want to do some model optimization. You may want to quantize. You may want to prune your model. You may want to compress it. But then basically you just do a torch.jit .script save on that model and provide it some .pt name, file name, and then from there we have pre-built binaries in JSON for Android, as well as CocoaPods for iOS. And then we have instructions on PyTorch.org that allow you to very easily deploy these onto your Android or iOS device. So when we thought about PyTorch Mobile, we didn't see this as a separate framework or something as a separate runtime. We felt this was really had to be kind of core to the workflow, just another deployment path, anything scriptable within the framework. Any model that you can script, for example, can be deployed to a mobile device. So it really is a clean way to do model deployment to something other than a server. So we're super excited about this. Okay, and then moving to quantization, we mentioned quantization in that workflow in that release at DevCon last year. We launched experimental support for quantization. So for those who don't know, quantization is a great approach to building efficient inference on server and in mobile devices using reduced precision math. In this case, we're talking about 8-bit integer. And what we've seen is really a 4x memory footprint, as well as 2 to 4x, and in some cases could be more depending on the baseline of compute. And there's really 3 ways to do this, depending on what approach you take, and basically depending on what type of architecture you're trying to optimize. Starting with dynamic quantization, and through to post-training quantization, where I have a trained model where we just want to quantize it, to quantization-aware training, where I'm actually doing this fake quantization, inserting these fake quantization layers within my network, gathering statistics while I'm training, and then basically pushing up my accuracy at inference time. And so I highly recommend trying all the tutorials out on PyTorch.org. We have tutorials that span all of these. We also have some recommendations on which approach works best depending on the architecture. And there's also a blog that's going out, I believe, next week that will actually walk through all of this in more detail and really give kind of a good hands-on view on all of this. Okay, moving to some of the other newer stuff. So PyTorch Elastic. So PyTorch Elastic is an Elastic framework that sits in the PyTorch org, as you can see. Really enables users to write fault-tolerant and elastic distributed training PyTorch jobs. So this is things like when you're running on a non-HPC cluster, i.e. the cloud. Maybe you want to use spot instances. Maybe you have this like mission critical production job. We have a lot of those at Facebook where if a node goes down, that's a big deal. These are jobs that are expensive. They may run for a long time. So this is critical. Also, as I mentioned, running on these preemptible instances on AWS is really cost effective. So spot instances. And then, being able to auto scale, have these dynamically changing like pools of compute, like having instances be able to go up and down. Maybe one goes down, it goes up. You can basically adapt to that environment in an elegant manner while your job continues to train. And you can see it's in PyTorch Elastic and GitHub, and there's also some integration with Classy Vision, which is a computer vision framework. Really shows a great concrete use case and something that we ourselves use here at Facebook. And then PyTorch RPC. So this is a new experimental feature in 1.4. It essentially enables applications to run functions remotely and then automatically handles all the autograd if necessary. So some of the example use cases we have are scale out applications. So if you had a parameter server running for things like reinforcement learning, or for example, distributed model parallelism. So if you had a really large model, span multiple machines, this is actually a great framework for it. It is very low level, so it's definitely for the more power user type of audience. But we have some great examples that show you how to use it for some of these types of problems, especially model parallel. And again, this is a feature that was released experimentally in 1.4. So if we just drill slightly down into the feature itself, so there are a number of different aspects. So we have the RPC layer, which is really running user code with given arguments on a specified destination. We have this thing called the RF, which is the remote reference. This tracks and maintains objects owned by the remote worker. We have distributed autograph support. So this connects autograph graphs on different workers into this global graph and provides this, this experience, which is very similar to how you would call autograd using a non-distributed environment, the lost.backwards API, and then a distributed optimizer. So this handles basically, just like you have an optimizer within your kind of standard workflow in PyTorch. This handles all of the distributed aspects of how it works with the RF of subnets and exposes this API that's again similar to how the torch.optim API works. And you can see the chart on the right here, kind of how things layer. And again, everything in green here is new in 1.4. So definitely take a look and try that out. Okay, I'm going to, at this point, hand it over to James Reed, who is a software engineer on our team and is going to walk through PyTorch JIT at a much deeper level. Thank you.